All right, so remember, there's two types of answers that you can get whenever you have to do separation of variables. Okay, one is called a general solution. So a general solution is when you integrate something. So you're going to integrate a function, and what you end up getting is its integral with the plus c in it, okay? This is called a general solution. So when you integrate a function, you end up with that plus c then, okay? So the f of x plus c is called our general solution. Now, there is another one called a particular solution. So a particular solution, given f of x equal to y, so they're going to give you some kind of numerical values. F of 0 is 3, f of 1 is 8. Okay, they're going to give you a point. Okay, so given a specific point, use it to solve the general solution. So right now we'll get into that. That's going to be the second half of the lesson, okay? But given a point, you're going to use it to solve a general solution. So you'll plug it into your general solution, find the exact value of c, okay? So I'll kind of put that right here. Finding c. You're going to find the exact value of c and then use that to write an actual equation that doesn't have a plus c in it. So it's called particular because it's one specific answer. Whereas the plus c is a family of solutions, right? Because it can be anything. It can be a plus 1, minus 1, a 0, a half, right? Those are an infinite number of solutions you can get for a general solution. Whereas the particular solution, we're finding the one solution that fits that point. Okay, so we're going to do two examples that are general first, then we're going to do two examples that are particulars. All right, for the most part on your AP exams, they want particulars, all right, not generals. So here we go. So for this, we're going to find the general solutions. Of each differential equation. So find the general solutions of each differential equation. So they usually do call them differential equations. That's kind of like one little hint. They'll mention like, oh, this is a differential equation. So it's a little hint that they're going to probably want you to do separation of variables. So here's example 1. dy dx is equal to e to the x over y squared. Now your job is to separate the variables so that one specific type of variable is on one side and another type of variable is on the other side. Okay? It's a lot easier than it sounds at times. Sometimes it's a little more complicated, but in this case it's not that bad. All I'm going to do is I'm going to multiply y squared to the left and I'm going to multiply dx to the right. Okay? I'm just moving them. Kind of like cross multiplication, right? That's all I'm going to do. So look, I get y squared dy equal to e to the x dx. Now, in order to find the general solution, where the differential equation came from, okay, I'm going to have to integrate. I got to figure out where did dy dx come from. So that's a derivative. So if I want to figure out where it came from, then I have to go backwards, right? The antiderivative or our integral. So I'm going to write integral of y squared dy is equal to the integral of e to the x dx. Okay, now this right here is what they call separation of variables. Okay, the top step is usually considered that, but sometimes they don't show that as a solution and they show the bottom one. So both of them, as long as you show both, usually on an AP exam, this would be worth 5 points. And I'll show you where those 5 points are once we're done with this problem, okay? But I'll show you how they usually classify these as 5 points. So all I've done is I basically rewrote it. I put my y's on one side, my x's on the other side, and then I'm just going to get them ready for integrating, okay? Now the integral of y squared is y cubed over 3 plus c, right? But I'm not going to write the plus c yet. I'm going to put it on the right side because I still have to integrate e to the x dx, which would be e to the x. And now I'm going to put my plus c. All right, now if I'm trying to solve for this function, then what I got to do is get y all by itself. So let me multiply everything by 3. So y to the third is equal to 3 e to the x plus c. Remember, the reason why it's not 3c is because 3 times a constant is still a constant. So I don't need to put 3 times a constant, just a constant. And then to get y by itself, I'm going to take the cubed root of everything, right? So this is y equal to the cubed root of 3e to the x plus c. And you're done. This is your final answer. This is your general solution. Now for this problem, if this were to come out in an AP test, it would only be worth 3 points because they're not actually asking you to plug in any numbers. That's usually another point. And to find the specific equation, that would be the next point. But the 3 points are usually given, the separation of variables gives you 1. So this would be 1 point right here for being able to do that. Doing the integration properly would be 1 point. Okay, and then solving for the equation would also be 1 point. The only 2 points we're missing are the finding the value for c by using the initial condition and then finding the particular solution. So, but that's going to happen soon. But here you would basically get 3 points on an AP exam for stuff like this. Separation of variables for doing your antiderivatives, as they call it, right? Your integration being done right. They sometimes even give you a point for putting the plus c. So this right here might be another point just by putting the plus c there. Okay, so this could potentially be a 4-point problem. Just this. All you need is 3 points to pass an FRQ question. If they ask you to do this, you can just do this. You get your 4 points, maybe 5 if it's particular, and then you don't even have to attempt the rest of the problem. You can move on. If the rest of it's confusing to you, then you stop, right? Hopefully that doesn't happen, but that's basically what they're looking for. So we're going to start off with a differential equation, dy dx equal to e to the x over y squared. And we're going to integrate both sides after we separate variables. And then after we do that, we just solve for y. If you don't show separation of variables, you automatically get a 0. Doesn't matter whether you got the right answer. They won't give you any points if you don't show separation of variables. Okay? So make sure you guys do that. Any questions on this one? All right, so let's try example number 2 here. So here we go. Example number 2. That's going to be dy dx is equal to x over y squared. So dy dx is equal to x over y squared. So again, start off by separating variables, okay? If that requires you to cross multiply or just multiply from left to right or right to left, maybe both, subtracting, adding, whatever it is, you got to get one set of variables to one side, one set of variables to the other side. So in this case, I'm going to cross multiply. So I get y squared dy equal to x dx. All right, so there's my separation of variables. Now I'm going to go ahead and integrate y squared dy equal to x dx. All right, and just integrate this. So you guys should know those steps for integration. So that's y to the third over 3 equal to x squared over 2. And I'm going to put the plus c over here. Now start solving for y and you're done. Again, these are called general solutions. We're not finding the particular ones yet, okay? We'll do the particular ones in a bit. So multiply by 3, I get y cubed equal to 3/2 x squared plus c. And then take the cubed root of everything. So y is equal to the cubed root of 3/2 x squared plus c. And this would be your solution for that. So what they're basically saying is if you take the derivative of this, it should come out to x over y squared. That's what your answer should be once you're done. Are we okay with that one? Not too bad, right? So again, this is probably going to be worth 3 or 4 points. Whether or not they give you a point for the plus c, that's up to them. But usually separation of variables is 1. So up top would be 1 point. Your antiderivative, so this part right here would be another point. So there would be points here, there, and here for sure. Okay? Whether they give you 1 for the plus c, it depends. I have seen some separation of variable problems where they give you 6 points for that problem. So the plus c becomes part of that. Okay? So, all right, let's do some particular solutions. But is everybody good with this? Separating, integrating, okay? Separating and then integrating. So here we go. Next part. These are particular solutions. Find the particular solution of the differential equation given an initial condition. Initial condition. An initial condition means they're going to give you a point, okay? So for initial condition, they're mentioning a point somehow. So it's pretty obvious in these problems, but sometimes you do have to read through a problem in the AP and they'll tell you the initial condition, but they're not super specific. They won't say like, oh, and you have the point 0, 10. But they might say like, at the beginning, before it started raining, there was 3 inches of rain already, 3 inches of water already on the ground. So that means when t equals 0, 3 inches was your height. So 0, 3, right? Sometimes you have to read into it. Sometimes it's obvious. Sometimes they will literally tell you f of 2 equals 7. Okay, so okay, x is 2, y is 7. I got it. So it depends on the problem. We'll see those when we start practicing. But that's an initial condition, okay? So here we go. Dy dx, this is for example number 1, sorry. Example number 1. Dy dx is equal to 2e to the x minus y. Now I did this one on purpose because I don't know if you guys remember how to break that thing apart. So y of 2 is equal to ln of 2e squared plus 2. So there's my initial condition. Now I know y of 2 looks kind of weird, but that's the same as f of x. Okay? So y of 2, that means x is 2, and y is ln of 2e squared plus 2. Right now we'll figure out what that value is. So it's 2 comma, and let's find out what ln of 2e squared plus 2 is. So natural log of 2, where's my e value? Where's my e value? Oh, it's down here. Whoops, that's not the right thing. Second natural log, there we go. E squared plus 2. So 2.8200, so it's basically 2.820, or I know you're supposed to keep 3 numbers after the decimal, but in this case it doesn't matter. So 2.82. There's my x and y. That's my initial condition. Okay? Now, do you guys know how to rewrite e to the x minus y? Like if I were to write 2 to the x minus 2, do you guys remember that that's 2 to the x over 2 squared? Right? Okay. So e to the x minus y would be e to the x over e to the y. Okay? Now, if it was addition, that means it's multiplication, right? But division is subtraction. So let's rewrite that. Because or else you can't really separate variables on this one. They're kind of stuck together as a power. So we got to rewrite them. dy dx is equal to 2e to the x over e to the y. That's what 2e to the x minus y is. Okay? Now, we're going to go ahead and start separating variables. So we get e to the y dy is equal to 2e to the x dx. Integrate here. So I have integral of e to the y dy equal to 2 integral e to the x dx. Notice I took out the 2 just so it's out of the way. Okay? It's not that I don't need it inside. I can leave it inside. It's fine. Okay? The integral of e to the y is e to the y plus c, but I'm just going to leave it e to the y for now. And the integral of e to the x is e to the x plus c. So I'm just going to call this 2e to the x plus c. All right. Now, at this point, I do have to solve for y, but I was given an initial condition. Given that I have 2 comma 2.82. I want to solve for c. So e to the 2.82 is equal to 2 times e to the second plus c. Okay, I plugged in my x and y value into my yet solved for equation. Okay, because I want to figure out what c is exactly. So at this point, I'm going to subtract 2e squared from both sides. So I got e to the 2.82 minus 2e squared, and that's equal to c. So let's calculate that. Let me move this over here. So I have e to the 2.82 minus 2e squared. So 1.9987. And I know 7 is supposed to round it, but remember what I told you guys, round or don't round, that's up to you. Okay? If you do round it, 1.999. Okay? Leave it at that. If you don't want to round it, 1.998. Okay? We'll just round it. Doesn't really matter. But C is approximately 1.999. So let me go back to my original problem right here. Okay. I'm going to bring that down. Okay. So e to the y is equal to 2e to the x plus 1.999. Well, I got to solve for y. What do I do? Say again? Yeah, do the natural log, right, of both sides. So ln of e to the y is ln of 2e to the x plus 1.999. Well, the left side is just y, and the right side just kind of remains the same. And here is my particular solution. This problem has the point 2, 2.82. We went through, we solved for everything we needed. Okay, right now I'll show you where the 5 points are probably going to be found. So there's probably going to be a point right here, solving for y. There's probably going to be a point right here, solving for c using the given initial condition. That's what they usually say, using the initial condition. Let's see, there's definitely going to be one in separating the variables, one in integrating, and most likely one in putting that plus c there. So this would be your 5 points. Separation of variables, your integrals, making sure you put the plus c, using your initial condition, finding your actual particular solution. We'll do one more of these just so you have 4 examples, 2 of each. Then I'll give you guys your assignment. Are we okay with this? These problems are usually associated with the problems that we like to call easy 9s. Okay? We tend to call these easy 9s because the rest of this is usually like, let's say there was an A, B, C to this FRQ on the calc test. This is normally part C. If there's an A, B, C, D, this is usually part D, usually. The other stuff that's in there is usually easy to find. They might make you take a derivative of something, or just plug in a number, or there's slope fields found with these types of problems. Okay, so usually when we're going through them, you might hear me reference it as an easy 9. Okay, meaning as long as you practice this, you shouldn't miss any points for these types of problems. Okay, there's some questions that are just considered, I don't want to say too easy to not get 9s, but I kind of want to say that. Like, you have to just know how to do some basic stuff, and you can get 9 points pretty easily. And those problems that we call easy 9s are important because those are the ones where you get all points, all 9 points, and then you get to the next question and you're like, I have no idea what to do here. I can maybe do part A. Just take a derivative, and there you go. I got 2 points. Oh man, well, 2 points doesn't pass the question. Well, that's okay. You got 9 in the other one. All you need is 4. That means you got 5 points to give away. So you can give 2 to that other question. Now you got 4. You've passed that question. You've passed the other question. You got 1 left over, right? That can go to another question, right? So whenever you get these easy 9s, it's really important that you guys get those 9 points, because that's basically your life raft for you maybe not even doing a problem, saying, I have no idea how to do this, right? Well, if you got 2 easy 9s, then that means you got 8 points to give. And if you got this question, you're like, I have no idea what to do, those 8 points can go right to there, and it looks like you did really well on it, right? So certain things, when we start practicing, you'll see them. Certain things I will reference as easy 9s, and then I'll tell you why I think they're easy 9s, okay? Those easy 9 problems are the ones that you guys got to practice all the time. Make sure you know how to do them, because That's going to be like your best shot of passing these tests. You got to get those right. Okay. The other stuff, sure, you miss a little bit here and there. That's okay. You've banked enough points. Okay. And not even that. Maybe you do great on the FRQ, but you did terrible on the multiple choice. You only need, Brandon, do you remember how many you need? Multiple choice, 8? Well, no, actually, I said you can get 8 if you just guess. Usually, statistically speaking, you can probably get 8. I think you need 12. So you just need like 4 more. And if you bank a bunch in the FRQs, that'll take care of it for you. Right? So you want to do really well on those FRQs, the best you can. Multiple choice, sometimes they're easy, sometimes they're tough. So, all right, let's do this last problem. So example number 4. dy dx is equal to x over y squared. And our initial condition, y of negative 2, is equal to the cubed root of 7. So let me just find out what the cubed root of 7 is. Does this turn on? Seven to the 1/3 power. 1.913. 1.913. So I have the point negative 2, comma 1.913. So why don't I give you a little bit of time? Separate variables, integrate, get it to the point where you have to solve for C. Okay, and then I'll jump in with you guys. Okay, I'm just going to freeze the screen. I'm going to freeze the video here, and then we'll get back to it. Hopefully with this little pause that I gave you guys, you did get to this point right there. So that's where you should be. Y cubed over 3, because the integral of y squared is y cubed over 3, equal to x squared over 2. And then plus c, of course. Okay? At this point, you're going to plug in your initial condition. Okay? So I'm just going to write right here, given that negative 2, comma 1.913 was given to us. Let's plug that in. So 1.913, and actually, it would probably be better for me to keep it as a cubed root of 7, wouldn't it? Because cubed root of 7 cubed would just be 7, right? So if you guys don't mind, I'm just going to keep it as a cubed root of 7. So negative 2, comma. I'm only doing that because I noticed I'm going to cube it, so I might as well use the cubed root. That's going to keep it nice and clean. So this will be 7 over 3 equal to negative 2 squared is 4 over 2 plus c. So I'm going to subtract it. So 7 over 3 minus a 2 is going to be c. So that's going to be 1/3. My c value is a 1/3. So let's put that c value back into that equation where I have the given that statement, right? Let's put it back in there. So y squared over 3 equals to x squared over 2 plus 1/3. Now to get my y by itself, I'm going to multiply everything by 3. So y squared is equal to 3 over 2x squared plus 1. Oh, what did I do? Oh no, you're completely right. Y cubed, thank you. Extra credit. All right, so y cubed. Thank you for that. So I don't know why I put y squared. Well, because the other thing's y squared, but I mixed that up. So yeah, multiply by 3, that's done correctly, yes. And then take your cubed root. So y equal to the cubed root of 3 over 2x squared plus 1. And that's going to be your solution. And again, your 5 points usually come in the the answer, solving for C, making sure you write your plus C, doing your integrals, and separation of variables. Okay? So if you don't do that, you get a 0 out of 5. You can still get a 2 out of 5 if you don't separate the variables. No, if you separate the variables but forget to put the plus C, they'll give you 2 points maximum. Okay? So if you don't put the plus C, they'll give you 2 points max out of the 5. So, any questions on this? This is a little bit more mechanical, right? So hopefully it's okay.